Good evening, my name is Vamshi Krishna. Here is a demo video about the knowledge-based search engine about the RAG as part of Unthinkable Solutions company assignment. So I have designed a high-level pipeline that accepts files, extract and concatenate text, split text into semantically coherent chunks, embed chunks and build a fires vector index, retrieve top chunks for a question, re-rank with a cross encoder and answer using an LLM constraint to the retrieved context. So I'll run the thing. So in the background you need to have an Ollama server. So because I'm not using any API, you'll have to have the Ollama in the background. So I have activated my virtual environment. I'm gonna run the script. So this has two API endpoints. One API endpoint to ingest files, which is PDF or text, and it creates embeddings and vector store. And the second endpoint is for querying. So now I'll be using the Swagger UI or the Swagger API to test the points. So at the first instance, I'll use the process method and try it out. This can accept one or multiple PDFs. So at the moment, I'll be using one. And attention, I'm uploading the most famous attention is all you need paper. So if I click the execute, embeddings and vector store will be created. So at the moment it's going on. After the successful creation, it will give a JSON output saying you can ask the questions. In the meanwhile, I'll give a code explanation. So a single file processor instant persistent across required. It holds the files index and chunks in memory, so later questions can query and users can query the uploaded corpus. And the data model, the question request class validates the ask question API body with one field user string. The fast API automatically parses and validates the JSON. So file process init class and has the method so that we could reuse the things. So vector underscore is none until built. You can see the text chunk cache for inspection or debugging, and embedding model as Hugging Face embedding, which has sentence transformers under the hood, which has a model BAAI, BG large and V1.5, which produces a 1024 dimension dense vector and works well for an English retrieval. A cross encoder to re-rank the candidate chunks. Cross encoders take the query and chunk jointly, offering a better fine-grained relevance than pure vector similarity. Now the first method is get underscore file underscore text. So here it iterates about all the saved PDF paths and loads them into LangChain document objects. PDF via PDF loader, which extract page-wise text, and text via text loader, which reads the UTF-8 encoded text, and then it concatenates all the page content into one large string. So you could see here. So it only supports two extensions, .pdf and .text, returns an error string on unsupported extent, and empty text or exceptions. So now document ingestion is over. Now text chunks. So I'm using a semantic chunker to split at semantic change point rather than fixed sizes. So with breakpoint underscore threshold underscore type equal to percentile and amount equal to 90. So boundaries are set where similarity drops fall in the top 10% of the change in magnitude, yielding fewer larger chunks unless there is strong topic shifts. So this will store and return the chunks of list of chunk strings. So semantic chunking is embedding driven. So embedding quality will directly affect the boundaries. So create vector store. Here I am wrapping each and every chunk string into LangChain document object. I'm building a fires vector documents with the Hugging Face model, and which has the save in memory to store the self underscore vector underscore store. And all chunk embeddings must share the same dimension. The selected model will ensure this. So the next method, get underscore conversational chain, it will create a prompt template that instructs the LLM to answer strictly from the context, specifies the fallback saying if the answer is not provided in the context, just clearly state that the answer is not provided, but not to create any synthetic answer. It also allows summaries when the user asks a summary. and LLM equal to Ollama of model. Now this will instantiate the Ollama Llama 3.2 with 0.5 temperature. Temperature here specifies the randomness of the model or creativity. So then prompt template is created taking template and input variables as context and question. So next time chain equal to load underscore qa underscore chain builds a qa chain using chain type equal to stuff which concatenates all the selected documents into the prompt context variable. So stuff I have used is because it's a simple. So for big documents you might want to consider map, reduce or refine for longer corpora. Now user underscore input. Now this will validate that a vector store exists or not, and if the vector store exists, it retrieves the top 5 similar chunks via the similarity. Here you could see similarity underscore search. Now it will re-rank the top 5 candidates with the cross encoders and will only keep the top 3. This improves the precision by considering query chunk interactions. Now it builds the QA chains and invokes the re-rank document and the question. So then it returns the chain's output text or the standardized fallback if it's missing. So this is about the user input method, user input function. Now process file function. So with this function will basically orchestrate the ingestion process, extracts all the text across the files and semantic chunks, the combined text, build the FIAS index from the chunks, create the vector store, get the chunks. Now it returns either a success message or the first error which is encountered. Now I'm creating an object of the given class. Now the first API endpoint is process underscore files. So I guess embeddings have been created. We could ask a question right now. So it says processing complete. You can ask question in the second API endpoint. Now let's try this out. Now let me ask a question. Explain about the self attention mechanism. Right, so I'll just execute. This will take a little time to load. So this second API endpoint, which is the first API endpoint, which is process files, will accept multiple PDF or .text files, saves each to the uploads directory with a UUID prefix to avoid collision. So whatever documents are uploaded, here you could see a unique UUID is created so that collision doesn't it avoid collision, and then it delegates to the file underscore processor dot process underscore file method, and then returns a JSON message string saying is it created or not. So after the successful embedding, you have seen here processing complete. You can now ask question, is the success message. Now I have asked the question, it is taking a little time. Coming up the second API endpoint, ask question. This will accept a JSON body with user underscore question, calls the processor user underscore input to retrieve, re-rank an answer, and then returns a JSON answer. So this is the main method which is used to call the APIs and all the endpoints with the UVCon as localhost. So the thing about this is I am not using any API, so all the data is local. There is no need for us to be scared that our data will be taken by any closed source LLM providers. But at the same cost, we need to have a good compute so that we could get all the models running in our local system. So I have called the Llama model. As you could see here, it shows Llama model 3.2 3 billion instruct model, which is good for RAG chatbots and which is non-OCR. It's only work for text. So you could see here the block count, context length, embedding length, and all the other properties. This is a 128K context window model. So if a success API call is done, it shows a 200 okay thing. So I'm just waiting for it. So I have asked explain about self attention mechanism. So it will take a couple minutes for that. We'll wait. Here the model has answered about the self attention mechanism, which you could see. The self attention mechanism is a key component of the transformer architecture. So it has given a good comprehensive answer. So this is in the document. So let us ask a question which is out of the document. Uh, let us say, let's ask how to cook noodles. Uh, let us see about this. So I have asked a question how to cook noodles, which is practically not present in the attention is all you need paper. So let us ask about this. Uh, on the other hand, you could see a successful request has been created. So it says 200 OK. On the Ollama server 2, a successful post request has been created. So I think it has answered our question. It doesn't deviate of the context. The answer is not provided in the context. The document appeared to be related to computer science and artificial intelligence, especially focusing on deep learning and neural networks and natural language processing. There is no mention of cooking or noodles in any of the document provided. So, however may the prompt be, it will not deviate about the context. So, let's add one more document and see about this. So, I'm adding one more document. So again I'm asking it to create embeddings. So it will take a little time. I have successfully uploaded 2 documents. All the 2 documents embeddings are created. So you can see a success message, a JSON saying processing complete. You can now ask question. The second form is about a company's eligibility declaration. So I'll ask a question about that. What is the eligibility criteria is the question that I'm trying to ask. So let's ask this. You could see the successful API hit process_files, so that it shows that we have successfully uploaded 2 files. We'll wait for a moment so that it answers. So it has answered what is the eligibility criteria. So it says the eligibility criteria. You could see it is actually accurate. So this is the thing. So it has successfully retrieved after putting in the 2 documents. So this is a little demo about my RAG PDF chatbot. You could see the API hitting over here. It took 26 seconds for the Llama model to answer the question. So all the uploaded documents are found here. I hope you like the video. This is a little bit about my RAG chatbot. Thank you.